I love you, Dad. I love you too, Mom, if you ever watch the video. So, like Jim said, my name is Michael Fairley, and I'm going to be talking a little bit about making computer games with Ruby. I work at a company called Braintree, and we make it easy for companies of any size to take payments online. We work with thousands of really awesome merchants, including a bunch of these that you probably recognize. So if you want to chat about payments, come find me later. We're also always hiring talented developers, and we do a lot of Ruby, and we're based out of Chicago, so come find me if you want to chat about that too. So I'm assuming that most people in here are web developers, that the Ruby you get paid to write is part of a Rails app or a Sinatra app, or you're writing libraries that you intend to end up in a Rails app or a Sinatra app. I fall into that boat too. The past 3 years that I've been doing Ruby professionally, I've mostly been working on Rails apps. But games are what got me into programming in the first place, and even though I don't really aspire to do that professionally anymore, I've picked it up as a hobby, something I do on the weekends when I want to just cowboy some code out and not have to worry if it's going to send money to the wrong place. So I'm going to share a little bit about this passion with you, and hope you guys will go home and try it out and find as much fun in it as I do. So I'm going to briefly go over some of the abstract stuff behind what game programming is, talk about a few of the really cool Ruby libraries we have for doing game programming, and then give you a quick demo of making Pong from scratch using these tools. But before that, I need to address some doubt in the room, which is Ruby the right tool for making games? Isn't Ruby slow? Don't games need to be fast? And the answer is yes to all of those. We luckily have, most of these Ruby libraries are actually Ruby bindings on top of C libraries that are quite fast. So we get a lot of the speed of C with the expressivity of Ruby, and it works out really well. I'm going to give you a quick demo of something I've been working on that should also cancel out some of your doubt. I've been building a Minecraft clone using Ruby. This is about 800 lines of Ruby for what you're seeing. And it's pretty dang fast for being a 3D game written in Ruby. So if that's possible, a lot of things are. This slide has just about everything you need to know about game programming as a general concept on it. At the core of every game, be it the Pong demo that I'm going to show you later, to Skyrim or Call of Duty, has a game loop at it. And the game loop is pretty simple. You do a little bit of setup before you enter the loop, put your game in whatever starting state you want it to be. And inside the loop, you continually update your game world based on player input or time or randomness, and then draw the state of the world out onto the screen. You do all of the mutation during the update and all of your output during draw. And that's basically game programming in 5 lines of code. So there's an awesome library for doing game programming in Ruby, and it's called Gosu. The entirety of Gosu is about 105 methods, and Active Record base has 500 class methods on it. So if you've gotten to know Active Record pretty well, you can pick up all of Gosu in a weekend. At the core of Gosu is the window class, and this is what you subclass to make your game. And once you do that, you're responsible for implementing 3 methods on it: initialize, update, and draw. And you'll notice that these are the 3 methods from the game loop: your setup, the thing that affects your game, and then drawing the state out onto the world. And Gosu makes all of these pretty easy to do. So Gosu has some tools for helping you draw on the screen. One of the methods that you'll use a lot is draw quad. You give it an x coordinate, a y coordinate, and a color for 4 points on a quadrilateral, and it'll draw them together and fill in what's in between them. There's also things like draw triangle and draw line. And then Gosu also has tools for helping you put text and images on the screen with about as much code. Gosu also helps you handle input from your players. So you can ask if a button is down, be it a button on the keyboard or the mouse or a joystick or gamepad. And then you can also get the coordinates of the mouse pretty easily. It's also pretty simple to play sounds in Gosu. You construct a sample class with a file name pointing at a sound file. And then whenever you call play on that sample, the sound will come out of your speakers. And Gosu also includes a bunch of helpers to help you do your math. There's a bunch of common math that you'll find yourself doing in 2D game programming. And a lot of it's high school level math, but as Brian Lyles demonstrated yesterday morning, we don't all remember our high school math. So Gosu just gives you some nice, correct semantic methods to help you out with this. So offset x and offset y here, you pass them an angle and a distance, and it tells you what component of traveling that distance on that angle is actually change on the x-axis or the y-axis. And similarly, you can pass this distance method 2 points, and it'll tell you how far apart they are. I've written a very small library that sits on top of Gosu, and it's where the rapid in the title of this talk comes from. Hasu helps you build Gosu games as quickly as possible, and it does this in a couple of ways. The main thing is hot code loading. So normally when you're building a Gosu game, if your game is running and you want to change something about it, you change your code, but then you have to quit the game, start it back up, and go back to wherever you were in the game to see how it's affected you. In Hasu, whenever you save your files, it immediately loads them, and the next cycle through the game loop, that code is in place taking effect. Similarly, with Gosu, when you have an exception, it crashes out the game, and you have to start it back up and find your way back to where you were. Hasu will catch your exceptions, pause your game, and after you fixed it, resume your game from where you left off. And since you're doing your game setup in the initialize method of your window, you only get one shot to do that because you only construct your window once. So in Hasu, you put your setup code in reset, and you can just hit the R key to reset your game. And with that, I think we know enough to do a pseudo live coding demo of Pong. And I say pseudo because I've pre-recorded most of it, so you don't have to watch me fumble through typos or or get stuck in a Emacs mode that I don't know how to get out of. So we'll start out by installing Hasu, which will also install Gosu. And pong.rb will be the main file for this game. We'll subclass Hasu window, and this is going to be our main window class. We'll give it a width and a height that are about 75% of this screen. And in our initialize method, we are going to have to call super up to the Gosu window, giving it the width, the height, and the fact that we don't want it to be full screen. And we call run on this class. And in a new tab, I'll run this, and we have a blank window. So let's put a ball on this. For Hasu hot code loading, you have to use hasu.load instead of require. So we'll load up the file with the ball in it. During our game setup, we'll make a new ball. And in the draw method, I'm going to ask the ball to draw itself onto the window. For now, the ball is going to consist of an X position and a Y position, representing the center of the ball on the screen. And I'll start those out in the exact middle of the window. And for drawing, I'm going to use the draw quad method that I showed you back on the slides. And here, x1 is going to be the left edge of the ball, x2 will be the right edge, y1 will be the top, and y2 will be the bottom. And I'll define exactly what those are in just a minute. And I'm going to make the ball be red for now. So x1 is going to be the center of the ball minus half the size of the ball. And we need to define size real quick. And then x2, y1, and y2 are all going to be pretty similar to what x1 is. And after we reset, we have a ball on the screen. And it's a little too small, so I'm going to bump it up. And you saw that as soon as I saved the file and switched back to the window, the new code had taken effect and don't have to close or reopen the game. So let's make the ball move. We now need to add the update method that Gosu will call as part of the game loop. And I'll just ask the ball to move itself during that. And the ball needs a direction and a speed to move. So I'll go ahead and add those to the ball. And I'll have it start out always headed to the top right with a speed of 4. And in move, I'm going to use offset x and offset y that I showed you back during the slides to figure out how many pixels in the x direction and y direction we should move to end up moving speed pixels along the angle. And then I can add those to the x and the y position. And we have a moving ball. And it's a little slow, so I'm going to bump up the speed just a little bit. Okay, so the ball is moving off the top edge of the window, but we really want it to be bouncing, so let's solve that. This is pretty straightforward. So during our move method, if we detect that the ball has gone off the top of the screen, we'll bump it back down onto the screen, and then flip the y component of the direction that the ball is moving. And we get a pretty simple bounce there. And I'll set up the ball to go down and to the right. And we'll do the same thing for when the ball moves off the bottom of the screen. We'll move it back up and flip the y component of its angle. And we get some bouncing there. I'm going to go ahead and extract out this flipping the y component of the angle into a method called bounce off edge. And if we were to have sound effects, this would be a great place to put a little pleep, pleep, pleep sound while you're playing. And we don't actually have access to dx in bounce off edge because we're computing it in move. So we can pull dx and dy out into their own methods. And this will prove useful a couple times. Okay, so it's a little boring that the ball starts off heading the same direction each time, so let's randomize it just a little bit. We don't want it to ever go perfectly vertical or perfectly just perfectly vertical, so I'll randomize it so it has a cone in which it'll move, and then half the time we'll also want it to go to the left as well. So we have some random starting state here. And now we need to handle what happens when the ball moves off the right edge or the left edge of the screen. So we'll give the two players scores, which will start out at 0. And then we'll use the Gosu font class, which takes a name of a font and a size. And we can use that to draw the scores onto the screen. So I'll draw the left score in the top left, and the right player's score in the top right. Okay, so now we need to actually change the scores when the ball goes off the screen. So during update, we can ask the ball if it's moved off the left side of the screen, and if it has, we'll increase the right player's score and reset where the ball is by constructing a new one. And we'll do the same thing for when the ball moves off the right side. We'll increase the left player's score and make a new ball. So we need to add off left and off right to ball. They are pretty simple. If the left edge of the ball has gone off the left edge of the screen, then we should think of it as being off left. And if the right side is off the right, then the same thing. And so now when the ball goes off the screen, the score on the opposite side will get incremented. But this isn't really much of a game yet because there's no way to play it. So we need some paddles. So our paddle code will go in paddle.rb. And we'll have a left paddle and a right paddle, which will use the same class with a different side passed to it. And like I did with the ball, I'm going to ask the paddles to draw themselves onto the window. So we'll make our paddle file with our class in it. And paddles are going to have a side and a Y position representing the vertical center of where the paddle is. We'll use the side that was passed in, and we'll always have the paddle start out vertically centered in the screen. And I'm going to cheat a little bit and copy and paste the draw method from ball, because it's actually sort of a general rectangle drawing method. If we had more time, we could extract this out into a superclass that both ball and paddle share. So the left edge of the paddle is actually going to depend on whether it's the left side or the right side. So the left paddle's left edge is going to be the left edge of the window. And the right paddle's left edge is going to be the right edge of the window minus the width of the paddle. So I'm going to go ahead and give paddles a width and a height that I think looks pretty good. And so the right side of the paddle is just going to be the left side plus its width. The top edge, the center of the paddle minus half its height. And similarly for the bottom edge. And with that, we should have some paddles showing up. But they still can't move, so let's make the paddles move. So for the left paddle, I'm going to use W for up and S for down. And we'll start with having W move the left paddle up. So when W is pressed, we'll call up on the left paddle. And the definition of up is pretty simple. Basically just take a little bit off the Y value. And then down will be the opposite. And we'll use S to have the left paddle move down. And it's moving a little slowly. Well, first I'm going to have the up arrow and the down arrow control the right paddle. So the paddles are moving a little slowly, so I'm going to extract out this magic number and bump it up just a little bit. So there's a little bit of a problem with the way our paddles move, and that's that they can move off the edges of the screen. Fixing this is easy enough. If while the paddle is moving up, its top edge goes off the top of the screen, we'll just nudge it back down a little bit. And same thing for when it's moving down. If the bottom edge goes off the bottom of the window, we'll just nudge it back up. And so our paddles are still kind of worthless because they can't block the ball. So I think it's time to handle that problem. So back in our update method, we'll ask the ball if it's currently intersecting with the left paddle. And if it is, we'll ask it to bounce itself off of the left paddle. And same thing for the right paddle. And it's not super important that you understand what this intersect method is doing right now. It's the sort of general are two rectangles overlapping each other in 2 dimensions. The math is interesting, but a little too subtle to get into right now. And so when the ball hits our paddle, the intersect method worked, but we don't have bounce off paddle yet. So time to add that. And when the ball hits the paddle on the left, we need to nudge the ball back off the right side of the paddle so that it's no longer on top of it. And the right paddle will need to nudge the ball just to the left to make sure they're no longer touching. And we can flip the x component of the ball's angle, sort of like we did when it hit the top and bottom edge. And this works, but it leads to slightly boring game. So we need to do something more interesting with the bounce. So what I'm going to do is when the ball hits near the center of the paddle, have it come off at a pretty steep angle. But when it hits towards the edge of the paddle, have it come off a little more shallow. So I'll take the difference between the center of the ball and the center of the paddle and divide it by the paddle's height. And this will give us a number between negative 0.5 and 0.5, with sort of the extremes being near the edges. We can multiply that by an angle and turn the angle a little bit, and we'll need to flip it for the paddle on the right. And now we should have a much more interesting bounce. So when it hits near the center, it comes off pretty horizontal, and when it hits near the edge of the paddle, we get much more vertical motion. And as one extra twist, whenever the ball hits the paddle, we should speed it up just a little bit so the game gets more challenging as it goes on. And so I'm a little bored of playing Pong by myself, so let's add a simple AI for me to play against. So during our update method, if the left paddle is an AI, we'll ask it to move itself and prevent the human from controlling what's going on. And we'll add a second argument to the paddle constructor to show whether it's AI or not. So we'll have to add the AI attribute and take it in our constructor. And then the AI's movement is pretty simple. If the ball is above it, it should move up. Otherwise, it should move down. And so this works, but we get this weird jittering effect. Oh, dang it. Oh, I screwed that up. I'll solve the jittering effect happens later in that one. So I'm done playing Pong now, but we still don't have a way to close our window. So we'll add the button down method to our Pong window, which will get called whenever a button gets pressed. And if the button that gets pressed is escape, we'll ask the window to close itself, ending the game loop. And that was Pong in 15 minutes. So I have the source code for all of this up on my GitHub if you're interested in going back through it. The commits are put in the order that I showed in the video if you're definitely interested in following back along the same path. So this link in the bottom right will take you to a gist with links to everything else I mentioned during this presentation. So there's a bunch of other gems that work well with Gosu, either built on top of it or just happen to work well alongside of it. Chingu is sort of an abstraction on top of Gosu that gives you a bunch of common behavior you probably want in most of your games, like mapping player input to method calls, or having menus, or drawing rectangles, things like that. Chipmunk is a 2D physics library. So the physics in Pong is pretty simple, but if you want to build something like Angry Birds or Scorched Earth, you'd be pulling your hair out trying to get all that math right. So each of those would be just a couple lines of Chipmunk code. Releasey is a gem that helps you package Ruby applications up into Windows executables or Mac apps if you want to distribute your games to people who aren't Ruby programmers. And Gosu also plays well with the Ruby OpenGL gem, which is what I did for that Minecraft clone I showed you earlier. And there are some somewhat active forums for Gosu, both people showing off their games that they've made in Gosu and other tools they've made to work alongside of it. There's also a really great, freely available online book called Game Programming Patterns. When I first started doing game development, my web development mindset and all the patterns I knew didn't really help me structure programs in any meaningful way. So this book is written by a game industry veteran who talks about a lot of the problems that games have as they start to grow and the patterns that have emerged over the decades for solving them. And that's all I have for you. Thank you.